You form your multiple choice box. You'll notice that that's pretty much already ready. I'm going to imagine a 1 there. If you don't mind, I'm not going to write it. That times the 1 will be 3. Reduce that by... What's wrong? Reduce that by 1, you get 2. That times that is 24. Reduce that by 1, you'll get a 1, which I'm not going to write. And if there was a 1 there, the 1 would times by the 45, leaving just a 45. And then that power of 1 would become a power of 0, which is why you don't see the x anymore, because anything to the power of 0 is 1. So that's our multiple choice box. Okay? Now here's the crucial insight. A genius way to graph a snake is to know where it's flat. Okay? If you know where it's flat, like if you know that it's flat there, and if you know that it's flat there, how else could you draw it? There's no other way to connect a snake through a flat point there and a flat point there other than what I've drawn. Equally, if I tell you that there's a flat point there and a flat point there, you can't really draw it any other way. It's not just connecting the dots, it's connecting the dots where I make you have a gradient of 0 at the point that you connect it. In other words, you have to have a flat tangent. I'll just convince you of that. If I make you draw a snake through that, it's dead easy. But if I insist that you make it flat when you go through the points, there's now only one choice. So, this is a very powerful technique because it means that you can graph a snake with just, or graph a cubic with just 2 points. Now, why has this business about that being flat got anything to do with calculus? Because remember what this was for? It was the 4th clue for M. It tells you the gradient of the tangent. So, if something is genuinely flat there, one way to imagine it being flat is that if you put a ball there, you could really balance it so it wouldn't fall down either to the left or the right. Then, that means you can put a 0 somewhere. Where? Well, it's multiple choice out of 4. So 0 expresses the fact that there's no gradient. In other words, that it's flat. So there or there. So, should you put a 0 there? Should you put a 0 there? Should you put a 0 there or there? Well, it's multiple choice out of 4. Amy Barlow, what's your pick? Top left, top right, bottom left or bottom right?
Top right.
Okay, so you're saying that I should put these x's there? Put 0 where x is. Okay, well if that's your claim, you need to have there has to be some reason to think that x is 0. In other words, you have to have some reason to think that you're on the y-axis. Do you have any reason to think that? That's fine, we do this by elimination, right? If you want to say x is 0, then you have to be imagining that you're dead in the middle. Okay, so Amy, do you want to have another go? It's now definitely not these, because they're x's. Multiple choice out of 2, there or there. You can just have a guess and we'll talk it through. Top or bottom? Bottom? Okay. Did you reject the top or have you just guessed? Okay. You would have been right to reject the top because if you want to put a 0 where y is, it means you have to be sure you're on the x-axis because that's where your height is 0. So we've eliminated every other possibility. We have to put the 0 there. And that makes sense because remember this is all about gradient and this whole thing was to help us work with gradient. So I now substitute a 0 there. Now I'm always making comment 104. Does anyone remember what comment 104 is? It's common factor. Okay, there's 3's all through there, right? A reductive divided by 3 never works better than when one side is a 0 because anything divided by 0 is 0 divided by anything is just 0. Now that's a quadratic which you solve by factorizing or using the formula or completing the square. I think this one factorizes pretty easy. And so the answers that pop out are 3 and 5. Okay, is everyone cool with that? That's where it's flat. Okay? It's going to be flat 3 out to the right and 5 out to the right. How high is it going to be when it gets flat? Well, multiple choice box. I'm going to put the number 3 somewhere. Where? Clearly in an x position because that's what 3 is. It's an x number. Top row or bottom row? Rhiannon, top row or bottom row? Top, because I want to know how high my flat point should be. That's what this row is for. It tells you about x and y coordinates. X is how far to the right you are or how far to the left. Y is how far up or down you are. So if you put a 3 in there, can you just everyone quickly work out what you get? It's quite a big number, but I think you can handle it. 3 cubed is 27. It is a bit big, isn't it? Yeah. 27 minus... What's 9 times 12? 108? Yeah. Plus 135? Okay, so it's 54. Okay? So in other words, you're going to need a pretty extreme scale here. Okay, so in other words, you're flat here. Okay? You're also flat at x equals 5. If you put a 5 in there, you get an even more enormous number. 125 minus 12 times 25 plus 45 times 5 is 50. There you go, you're done. That's your graph. Okay? Does anyone want to ask any questions about that? Now, by the way, there's never really any excuse not for doing the y-intercept. The y-intercept's dead easy. Just sub in 0. Where? If you sub in 0 there, you get 45. That just tells you the graph is incredibly steep when it hits the y-axis, which it sure looks like it's going to be. Subbing in 0 for x here will give you the y-intercept. It's 0. There you go. So there's the graph. Okay? Amy?
How do you know the snake goes that way rather than the other way?
Because that flat point was higher than that one. It's the only way to connect it. Yeah, and that's why doing the y-intercept is always a good idea. Because if you do the y-intercept, there's now absolutely no doubt. You've got to connect that any way you can, as long as you're crossing the y-axis. You've got to go through that flat, you've got to go through that flat. Just muck around, you'll see it's the only way. Okay? Now, I'll